phagocytic thing. The monocyte is the one, y'all, let me just mention this to you right now. The monocyte's the one that tends to like to leave the circulatory system, move out into the cells and the tissues, and become known as, quote, a macrophage. A key macrophage, M-A-C-R-O-P-H-A-G-E. The monocyte, but we'll talk about these individually a little bit later. We're not going to get into those right now that much. All right, thrombocytes, I like the thrombocytes, the platelets. Did the machine take all your money?
Yeah. I had to go to the other store. I was thirsty.
All right, okay. The thrombocyte, y'all, is the platelet, and the platelet is the main thing about the platelet we will go into in good detail. Because is there anybody in here, is there somebody, first of all, let me ask you, is there somebody that you know that the doctor has asked, are they taking a baby aspirin or children's aspirin daily? Some of y'all know? Anybody? Well, now you all know somebody because you're looking at me. Now you all know somebody. Because I was asked to do that when I had a little issue that evolved about 13 years ago. A heredity type thing, I think, and also being around secondhand smoke too much. But my mother, I did a study on myself, and my mother smoked. She died as a result of it, chronic obstructive pulmonary disease. When I was a little boy, growing up, there was smoking in the car, there was smoking in the house, there was smoking everywhere. And now we know the effects of secondhand smoke, and I think it had a drastic effect on me. I really think it did. I never touched one, never smoked one in my life. But I think it had a drastic effect on me. I really seriously do. The paper I did on lung cancer, you'll find how many thousands of people die yearly in the US of A as a result of secondhand smoke. You'll read that. If you read that paper I did on lung cancer, you'll read that. Serious sturf, as they say. Serious sturf, okay? All right, now anyway, so secondhand smoke, but anyway, and heart disease go hand in hand. Okay, everybody, now right here. All right, now this right here just shows, I'm just showing you right here, a red blood cell, a hemoglobin molecule. The hemoglobin molecule is very similar to the chlorophyll. And now we're seeing some pretty weather, and we're seeing some green out there, and all that, all the green is the chlorophyll. The main difference in the chlorophyll and hemoglobin, the main difference in chlorophyll, I just always point this out because I used to teach botany. The main difference in chlorophyll and hemoglobin is that chlorophyll has magnesium, whereas hemoglobin has iron. Other than that, they're very similar molecules. Chlorophyll in all these green plants and the leaves and the grass, everything you see, the chlorophyll is very similar. The hemoglobin. All right, so, but anyway, that's just, and each one of, now here's what's mind-boggling. I can't even count this high. I was never the greatest mathematician. But the highest math I had was pre-cal, and I had to really work with math. Math wasn't college algebra and college trig and pre-cal and analytical geometry and all that stuff. It just wasn't my favorite tool. But it's hard for me to think in terms of this. But each one of those little things, look, 8 micrometers are microns. I mean, you have to see these things. You look at blood in 2401. If you didn't look at them on high power, you could hardly see them. See little red dots? Each one of those little things, as small as it is, has 280 million molecules of hemoglobin. Each one has, in other words, the red blood cell is a convenient way of packaging hemoglobin. So it just doesn't go everywhere. So there's a hemoglobin molecule and so forth. That's just kind of showing us. Now this right here, there's a lymphocyte. All right, there's a, pick out NEB. N-E-B. Neutrophil, eosinophil, basophil. This is the one that's this is on that test, Shasta. You like to work those practice exams. I asked one which is commonly referred to as the polymorphonuclear leukocyte. It's that one right there, the neutrophil. That looks like 3 different nuclei and it's only one. That looks like a couple of different nuclei and it's only one. The nucleus, the way I usually tell about the lymphocyte, the nucleus seems to fill the whole thing. Just the big blue blobs under there, that's usually a leukocyte. And then a monocyte, that's all the nucleus there. And this one kind of, sometimes this one kind of shows up kind of kidney shaped as far as the nucleus, but you're not going to have to separate those. We'll look at them one more time when we get into the lab part after we finish the cats. We'll look at these, but they're the white blood cells, just kind of give you an idea. There's another. That's just another view. See the nucleus, looks like it's 1, 2, 3, 4, maybe 5 nuclei. There's only one nucleus. Polymorphonuclear, many-shaped. That's all polymorpho means. Poly means many, morpho means shape, nucleus. There's the kidney shape. See, kind of a kidney in the monocyte, kind of a kidney. There's the lymphocyte. That just says a small lymphocyte. Fills the whole thing. Eosinophils. How many of you have allergies? Any of you suffer from a little allergy problem? Well, when your allergies kick in, everybody, this count goes up. Eosinophil usually goes up with allergies. That's the white blood cell that kind of elevates with allergy situation. All right, we'll talk about those later on. All right, okay, so that's pretty good right there, just showing those. There bees the blood platelets. All right, there bees a little platelet right there. And we're going to talk to you exactly what aspirin does. Exactly what aspirin does to inhibit platelet plug formation and blood clotting. How does the little aspirin work? Okay, and it's pretty cool, you know, it's pretty good.